why is science teaching still predominantly didactic? You know, as I work a lot with schools and with teachers in our local context, one of the things I hear from teachers is that we have lots of content to cover. We really have lots of content to cover. Now, I'm not sure if that's the situation in your country. Is that true? I see you nodding your heads. Yeah, so it's an international phenomenon. We have lots of content to cover. So what do teachers do when they have lots of content to cover? What they do is that they begin to apply what I call a pour-in way of teaching, a pour-in approach of teaching. Now, let me illustrate to you what pour-in approach really looks like. Here's the teacher, filled to the brim with knowledge, almost overflowing. And here we have the students, and the students are like, empty vessels. And sometimes they make a lot of noise. The pour-in approach of teaching, if you go into the classroom and you take a look, is something like this. Here is the teacher talking all the time. Talking, And then I realized that the students who are seated behind, they are also talking. And we have the two groups talking all the time. But I've discovered something. They are not talking about the same thing. So here we have the teacher filled to the brim with knowledge, and here we have the students who are like empty vessels. And so what do teachers do? Because they have lots of content to cover, they pour in. They just pour in. Now, of course, pour-in is recognized as one, didactic is recognized as one, a valid way of teaching. The big question is this way of teaching good or bad? Now, I get asked that question many times over. Is it good or bad? I was once asked over national radio, is this good or bad? Now, if you are a professional, when people ask you that question, don't give a straightforward answer, yes or no, good or bad. You must always say, it depends. Of course, the next question that will ask you is, what does it depend on? Okay, well, it really depends. It depends on the type of knowledge, it depends on the type of students, it depends on the time of the day, it depends on who the teacher is pouring in. It really depends. But all things being said, what the teacher does is the teacher just pour in. Now, there's a very strange phenomenon when you pour in knowledge like this, and this is known as instant vaporization. So when you pour in knowledge, poof, the knowledge disappears. And that's what happens when teachers pour in. Now, as I've said, it's not an issue of whether is that good or bad, right or wrong. I think the bottom line issue is what learning theories do teachers subscribe to when they teach in this manner? And do they know under what context is this an appropriate and valid way of teaching? I think it's a big question. Because when we do pour-in approach, the idea is knowledge is like a commodity which you can neatly package it and then you can just transfer. And so here we have teaching, here we have learning. And I know a lot as a teacher, I can teach you. Now if you ever hear your staff, your teacher saying things like this, oh, I can't test my students because I've not taught them. They won't know anything about it. You and I know that that's not quite true. Especially if they're in secondary school, they've gone through at least 12, 13, 14 years of primary school education, elementary school education. They come with all sorts of ideas in their mind. If you were to just simply ask a group of students, what is ratio in mathematics? What is ratio? The students will quickly raise their hand and say, sure, I know, ratio is ... 1.2, that's the ratio. The better students might say, sure, I know, ratio are fractions. Then we would ask the question, why do you call the same thing by two names? Ratio and fractions. How are they similar? How are they different? And some of them might know, sure, I know, ratios are a comparison of two things. But it can be 1.2.3. It can be more than two things, So students come to us in our classes with lots of ideas. And I've just run two runs of a 2 full-day session for Ministry of Education on the constructivist approach to science learning. There's so much to learn about the students' misconception. Oh, that's not a politically correct term. I should say students' alternative conceptions, which may be misconceptions, okay? So, lots of content to cover. That's a common refrain I hear from teachers. The next reason I could suggest for us why science teaching is still predominantly didactic is again this thing I hear from teachers when they say, no time, no time. Now this is very Singaporean, okay? In Singapore, I think you would have realized in the last 2 days, we packed everything and we rush here from here to there, we rush from this place to that place. Sometimes they say we are better known as Russians than Singaporeans. So, no time, no time, we have no time. And that's why we have to cover the syllabus instead of uncovering it and discovering it, we have no time. So, that's what the teachers say. Pause for a moment, think for a while. Is that the real issue? This issue of time, I have a good answer to it. Because I've thought about it for a very, very, very long time. No pun intended. Okay? But the whole issue of breadth and depth of curriculum, I have a tentative answer to it. Because that demands sometimes professional judgment. But the issue of time, I have a real answer to it. So when teachers say that no time, no time, no time, I think we really have to think through, is that a real issue? Well, I submit to you this morning that that's not the real issue. Because the reality is, time is the fairest commodity. Now let me check with you. Is this something that you hear a teacher say too, that they have no time, that they have to pack everything in, they have to deliver this content, this syllabus? Really that's not the issue. You and I know time is the fairest commodity. Now if you don't believe that, let me show you once and for all and confirm that time is the fairest commodity. A lot of teachers rush through the syllabus. They say we have no time, no time. They're like this very short rope, And then there's some teachers with proper planning, they manage to accomplish what they set out to do. Well, I have 3 aspects about time. Alright, one is this whole idea of a perception issue. No time, no time. It's a perception issue. They feel it, right? They think it is, but it's not the real issue. For some teachers, it's a planning issue. They don't plan their time well. How did they not plan their time? Just take a look at the lesson design and you will discover that. I just came from an English class just the other day, and this was a secondary 2 English language on procedural writing, a type of genre that they do, And part of procedural writing demands that the students are able to give instructions. And so what the teacher did was, in a 60-minute lesson in the double period, the teacher had then solved a puzzle. And this is one of those puzzles involving river crossing. You have some people on this side, the policeman, the father, the mother, the children, and you have a raft that can only take 2 people on board at any one time, and you're supposed to bring everybody across to the other side. And so the teacher says, why don't you all work in groups and then try and solve this puzzle? And in solving that puzzle, you have to give instruction. Right? So that's part of the procedural writing. I observed that lesson. I've discovered that 33 minutes was spent on solving the problem. Now you ask me whether the students are engaged. They were totally engaged. They were very on task. They were excited. 33 minutes spent on that. 8 minutes, the teacher got 2 groups to come up and present verbally how they give instruction. And when I listened to the verbal presentation, it was like this. The first group that came up was, okay, let's put the father and the mother on the raft from this side, and let's move them over to this side. Leave the mother there, the father comes back to this side, okay? That wasn't too bad. Right? The second group that came up, okay, let's put parents here, this side, this side, that side. And that's the procedural writing. And you and I know that in terms of the content, in terms of the depth of understanding, that's grossly inadequate. Because in procedural writing, you have to use things like imperatives. You have to use things like positions, time, and all that. So that's not adequate. 8 minutes was spent on that. And the remaining 19 minutes, what the teacher did was give a PowerPoint presentation. This is how we write procedures. Please turn to your textbook, page 247, and there's a work example there on how to bandage a wound, giving instructions how to bandage a wound for 1st degree burn, 2nd degree burn, 3rd degree burn, and the teacher went on to describe about 1st degree burn, 2nd degree burn, 3rd degree burn, and I was sitting there behind looking at the lesson. I was wondering, is this a lesson on first aid? So I asked the teacher, this lesson is about procedural writing. Why did you plan it like this? And she said, oh, this is an introductory lesson. This is an introduction. Now I have no issue with it if this is part of a total plan. But if I hear teachers say, I have no time, no time, no time, then why use 60 minutes for an introductory lesson? And I have a problem with that. An alternative might be like this. If I were to take that class, I would line up the class on the side of the classroom before they enter, and the lesson could start there. I could tell the class, for example, okay, now class, today we're going to do procedural writing. All right, I'm going to give you some instructions. Listen carefully, and when you go in and sit down on your seats, I want you to write them out and then come and share with us. Are you ready? And they'll say yes, and I'll say, okay, line up in twos. Walk quietly into the class. The lesson of procedural writing has started. So this is often an issue that I hear from teachers. No time, okay? But if there's no time, you really got to look at your lesson design and your curriculum design, okay? Well, there's a third group of teachers, surprisingly, they have lots of time. And they don't know what to do with that time, okay? So they might go for high tea in some posh hotels like this, you know? They might spend their time, you know, somewhere else. The reality about time is the fairest commodity. How much time do you have in a day? You have 24 hours. How much time do I have in a day? I have 24 hours. You don't have any more time than I have. I don't have any less time than you have. Of course, I'm not saying that, you know, the demands are not there. The demands of teaching are very high these days. And I know that people have different capacities. But that aside, time is the fairest commodity. If you don't believe it, don't blink your eyes. Time is the fairest commodity. Wow. No more, no less. Okay? So no time is a common refrain, but it's not the real issue. The real issue, if you ask me, besides planning, the real issue is one of purpose. It's one of vision. What do we as administrators, what do we as curriculum designers, what do we as teachers hold as our vision for educating our young? I think that's so much important. Not just for me as an individual, as a person, but for me as a professional as well. Well, the third reason is a perceived lack of control. Some teachers worry that when they begin to do inquiry-based, you might get chaos in the classroom. Now, it doesn't mean that really. There's a lot to plan before you actually carry out the inquiry-based lesson. And once you plan it well, it doesn't have to be chaos in the classroom. One of my favorite sayings, my tagline is, the more you prepare outside class, the less you perspire in class. And the less you perspire in class, the more you inspire in class. And I think as all good teachers, we seek to inspire our students for the love of learning. Ineffective questioning is another example, is another reason why teachers do not engage in inquiry-based. Because they really don't know how to ask good questions and ask it appropriately. I've been observing schools' lessons, as I say, so many times, and often not is supported by research. And the research tells us teachers ask questions at the rate of 1 or 2 questions per minute. So in a 60-minute lesson, it's not uncommon to find that they ask something like 60, 70 questions. Now you're wondering to yourself, how is that possible? How can teachers ask so many questions within that lesson? It's very possible. I've seen it happen in class time all the way from kindergarten to junior colleges. It's the same thing. It's happening in class. The teacher walks into the class and gets the class ready and starts a lesson. Okay, now children, are you ready for lessons? Can we get into groups? Can we start the lesson now? 3 questions really. Within how many seconds, And some of these questions, they don't even concern the conceptual depth of the knowledge that we want them to learn. Okay? So ineffective question. Well, here's one. How long does it take to charge up the capacitor? And the answer from the student, not very long. We never ask this kind of questions in science exams. We would always ask, what is the time taken, bracket in seconds, for the capacitor to be fully charged? We never ask it. Here's another one. Like poles of magnets dash, and 1 mark for that answer. Like poles of magnets dash. You and I know the answer. Like poles of magnets repel. Okay? But the students don't think the way we think. So the answer that came from them was, like poles of magnets are the same. Now do you think the teacher marked this answer right or wrong? Obviously wrong, because in the marking scheme, there is a key word which the teacher is looking for, repel. Okay? So the teacher marked it wrong. But we train our students to do inquiry-based learning, and now they're so well trained, they challenge the teacher. Teacher, why is it wrong? Like poles of magnets are the same. You know, north, south, south. Now you know what the teacher told the boy? The teacher told the boy, come here. If I want you to write your answer, like poles of magnets are the same, my question would be, like poles of magnets, dash, 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 one word, understand? And he still doesn't take no for an answer. He challenges the teacher. Actually, never say in your instruction, one dash, one word. Well, ineffective question. Teachers ask questions at very fast rate. In a 36-minute lesson that I observed, a science lesson, the teacher asked, in a 35-minute lesson, the teacher asked 36 questions. That's about a question per minute. Okay? And in those 36 questions, 27 questions were content related, and then you have 9 questions that were instructional type. And when I analyzed the 27 questions, only a few were on the Bloom's taxonomy level 2 understanding. Majority of them, they were on the recall or remembering. So ineffective questioning is another reason. I think we really have to look into this. The last reason is I feel that some teachers may never have experienced it. Inquiry-based learning themselves. And hence they do it like this. You know, can I have your permission to share you a personal life story? Would that be okay? That's all right. Okay, you like it. Okay. Now I went into the army not knowing how to swim. Okay. You know, in Singapore we have all males have to do national service. So I went into the military as a recruit not knowing how to swim. Now the reason why I don't know how to swim is because I'm the only child. Mind you, I'm the only child, not the only son, but the only child. And as only a child, my mom said, you know, you cannot swim, you cannot ride bicycle, you cannot climb trees, you cannot go to the beach, you cannot, you know. This is typical Singaporean style. Okay? Parents are overprotective. Okay? In that era, today's moms are different. Today's mom is everything you should try. And hence the child get an overload of math tuition, music lesson, you know, so it's the complete reverse. It's the only end of the spectrum. But I missed out all those opportunities, so I went into the army as a recruit. I didn't know how to swim. Now, it's very trying, very grueling if you go to the army and don't know how to swim as a recruit. Okay? So every evening, after a long day's training, someone at the bottom of the block will shout, "Fall in!" And all of us will rush down, and we will form a platoon of non-swimmers. And we'll be marched to the deep end of the pool, you know. And there will be this gentleman down there, he's known as the physical training instructor, the PTI, the most feared person in the army. And he will say, "Single file." And he will give a command, he will say, "Jump." Now I knew very well in the army, when they give a command, "Jump," I must jump. Now I cannot turn around, "Excuse me sir, what are the 10 good reasons for jumping?" It's not inquiry based. Okay? It's a command, alright? So you know, when we do inquiry-based learning, we have to know also what we call epistemic cognition. Where are the boundaries of the application of knowledge? When do we not want our students to ask questions? That's a question we have to think about. Maybe as we talk about inquiry-based. Anyway, he said jump, and I jumped. Mine is the deep end of the pool. And when I jumped in, the laws of physics took over. I'm denser than the density of water. Because of fear, panic, I struggled and I began to sink. Now as I was sinking, what the PTI would do is, he would throw me a rope, and that would be my line of hope. And I'll grab the rope with all my strength, and I'll start to pull. And as I pull, you know what you'll do? You'll let go. And then I pull, and you'll go. So I begin to drown further, I begin to sink deeper, alright? Now, but one thing you can bet in the army, one thing for sure you can be certain, is that they won't let you die. Because if you die, they die. Okay, so they won't let you die. So as I was really about to drown, they will use a long pole and they'll haul me out of the swimming pool. Sometimes they make us go to the diving board. Now I'm a non-swimmer, but they say jump, and I knew better I had to jump. Okay? Now I have 3 children. They all know how to swim. They have passed their swimming test, proficiency test. You know, they got their gold star. So I've got 3. Now imagine my son who is in year 1 university. Now imagine if he cannot swim. And I'm being the good father, and I want to teach him how to swim. And I will say to him, "Come son, follow me." And I'll bring him to which end of the pool? Excellent listener. Deep end of the pool. And I'll issue a command. I'll say, "Jump." And if he doesn't jump, I'll nudge him in, and he'll go in. And because he cannot swim, he'll struggle. And what would I do? Yes, I'll throw the rope. And what would he do? He'll catch the rope, yes. And then what would I do? Sorry? No, cannot let go. It's my son. They can't let go. It's my son. I will tarik. I can't let go. Okay, so he's my son. I hope you had good fun with that. But behind every fun, I think there's a meaning to it. Okay? So I hope you don't go away laughing and your feedback says Dr. Ho is an entertainer. That's it. So I believe in meaningful fun. I believe my own learning of, my own theory of learning is learning should be enjoyable. It should be fun. It should be engaging. Okay? But what's the meaning behind it? Here's the point. Okay? The way teachers teach is heavily influenced by the way they were taught. And we know this from research. So if teachers have not experienced inquiry-based learning, it's going to be a big challenge to get them to do inquiry-based science teaching. They will have all sorts of ideas, all sorts of preconception, which might hinder them. So these are reasons that why, after all these years, but good news, things are changing. It's got to start with someone. Right? And over in Singapore, the Ministry of Education has really gone into high drive trying to do this. So, good news.